All right.
We're officially live.
Perfect.
So was everyone able to do the part 2 preparation?
I did it.
I looked over it.
Yeah, I was able to do it. Any questions on that? I'm trying to think if I have any.
Well, we're supposed to give each other our samples that we came up with.
That's right. Compare them.
To I printed mine out this time.
Smart.
So I put my little mean. So I can mark everybody's mean and then just show it to you. If you get, then you'll be like, okay. Check.
Cool. I can give you my mean if you want.
Okay.
My mean was 47,360.
360.
Yeah.
Okay. And then what was? Anybody else do that? Do it.
I never cut them out.
You don't have to cut them out. You can go to there's a little link and it just randomly gives you 3 integers, and then you look at the box and it like I had like my things were like 21, 3, 5, 10, and then you write the corresponding salary from the chart, and then those are the one. So those are the 5 you randomly selected, if you will, and then you just take their average. So that's how that works.
Pretty easy. Just take like 5 of the 5 random squares, add them up, and divide them by 5.
Yeah. Did you do it, Thor?
No, mine doesn't let me open up the links.
Oh.
Or an issue with my computer.
That would help.
So I did mine in Vincent. So here it is, and I did mine, and my mean was like right here, and then Vincent's mean was like right there. So we're both right there, all around the.
Okay.
So it just kind of shows that it's normal.
Yeah, makes sense. Just kind of proves that it stays on the bell curve. The normal.
So, I have it written down, the whole law of large numbers versus the whole central limit theorem.
Mm-hmm.
But exactly, okay. I have it down here. The sample size is large. The sample mean will be approximately distributed. The law of large numbers states that the sample size increases. The standard deviation gets smaller, and the sample mean is closer to the mean. So the one is the large numbers, though. Is this more the normal distribution, right?
Yeah.
I mean, technically, that the normal distribution is no matter what the sample is, but
yeah.
So, like, say you roll a die times, it's going to be pretty close to 1/6 of the time you get each of the numbers. Whereas, if you only roll it 20 times, you're going to get really variant.
Right, that's the central limit theorem. Because that's as the sample increases, then the deviation decreases and it becomes closer to the mean. But I'm just trying to me, the law of large numbers almost says the exact same thing, but if it's just a different way of saying a normal parent distribution,
You can take that with you.
I just don't understand why it has to, why it says large number.
So from the video, I think that the law of large numbers is actually the one with the like the what Thor was explaining, where like the larger the sample size is, like, or at least the more times you would like roll the dice or flip a coin, the more accurate and
Yeah.
the more accurate it becomes. And
So from that video, these are the, I just printed that slide.
oh yeah, that he has.
Uh-huh. I do them all. I just photocopy each slide and then I just put them on a paper like that. But this is the big one. It accidentally printed. But because it says as the sample size n increase, this is central limit theorem. As the sample size n increases and becomes large, the distribution of the sample means become approximately normal. And the other one says as the sample size n increases, the sample mean draws closer to the population mean.
So the standard deviation is what gets smaller.
In the law of large numbers, right?
And large numbers. In the central limit theorem, that one's saying that it's approximately normal. It's just kind of, I don't
So
know.
it's just that because the odds go up or something, right? I mean, kind of. Because the deviation,
They're really close to the same thing.
Yeah, they're pretty
Yeah.
close.
but yeah,
It's
that
kinda
seems to be
confusing.
like a big thing that is like on the test and stuff like that, knowing the differences. So I'm just I just wanted to really
Go over that.
know the differences. Yeah.
On the part two, to the part two or the preparation, they have the answer like on the answer key, the differences, and that helps
Yeah.
me too.
Yeah, I actually copied and pasted that right there. So I would have like
Kind of the
verbatim.
guy.
Yeah. Well, just because I didn't want to learn it the incorrect way. So instead of putting it in my own words for study purposes.
Yeah, for sure.
So
That
they
is
just feel like they say similar things, but then they don't say some things. They just, one is talking, I guess law of large numbers always talks about the deviation, and I don't think that central limit theorem mentions the deviation. It only talks about the population and the mean. So, all right, well, I guess it'll sink in. I mean, I pretty much understand it. I got all the answers right, but I just wanted to,
To rehash it.
yeah.
Just
Yep.
think it in.
it's good to bring it up here to see what everyone else thought. Because at least I'm on the same boat as you.
Yeah.
So what did you guys get on your mean again for your sample?
I got 44,000. 44,540.
Yeah, I got 45,620.
You got 45,620. Okay.
So it still stays on there.
Yeah. Yeah.
Yep, pretty close. And there's a ton of different variations, so
Yeah.
crazy.
0, pretty close.
Alrighty.
So, okay.
Shall we move on to the group quiz?
I say yes.
Okay, let's do it. Okay, number 3. We're taking a sample size of n equals 5. What is the shape of the distribution? Means histogram when the parent population is right skewed. Pretty sure it's just skewed right. What do you guys think?
Yeah, I would assume skewed right too. If it's so small. Actually, I don't know.
Well, I linked that thing, so I think because you go up, I won't be able to see you guys because I have to make it wider. If you go up and you skew it, and so it's skewed to the right, and you have the 5. I guess it depends on what you're doing. Because if you only do a sample of 5, you really get nothing. You know what I mean? You have to do it a lot of times before you start to see any real pattern. What did it really say?
With the practice, when I remember, like with my thinking, it's like if the sample population is, or the sample size is large, then that's when it's normal. When it's small, it stays like skewed right or skewed left. That's how I thought of it.
Yeah.
Yeah. And that's because you have to get really high numbers. Because if you keep dropping them, you keep dropping them. Well,
Yeah, I would say skewed right.
I don't have That's my only one.
See, for number 4, you're taking a sample size of n equals 100. What is the shape? Then that's normal because it's a large. Is that your son, Thor?
It is. This is Zale.
Zale.
Yep.
Very cool.
Can you say hi to everybody?
Hi.
Hi, Zale.
So for number 5, since it's
So we were thinking 4 is normal. Is that right?
Yeah.
Yeah. That's what I think.
then it would still be normal on number 5.
Yeah, I would assume that.
Because that's the whole, if it's normal, it doesn't matter what n is.
Yeah.
Yes. Yeah. Okay. Yeah.
Same with 6.
Same thing.
Same with 6. So let's see.
Well, even with N100, if the parent population is skewed right, wouldn't then the 100 be more skewed right, even since the parent population is skewed? So even though you're taking more samples, it's already from a skewed distribution.
Yeah. But in the video, it says that it shows like 50 even was a large number, and
Please.
I don't know. In the video, it said, somewhere I read, it said, which is a large number. Let me see. Yeah, it says, suppose a random sample of 50 students were surveyed concerning internet usage, and then it says 50 is considered a large sample.
Mhm.
And so in the end, it says it's right skewed distribution, and with a sampling of 50 students, it becomes normal. So that's a specific,
Example.
so that's how I would, I mean,
Yeah. It's kind of how I'm remembering them. I can't really explain it too detailed yet in my head, but I just like remember.
oh, I hate choose all correct responses.
Well, from the questions that we just had,
Data are
we just kind of found out, right?
Yeah.
that would still be.
So from what I gather from those questions and stuff, so if the population is normal, for either a sample size that's small or large,
Yes.
the population is skewed right, but the sample size is large.
Yeah.
Yes.
Correct ones, right?
Yeah, that's what I got.
So I have first, second, and fourth.
That's what I have.
Yeah.
Cool. Which one is this? Oh, okay. I got C for number 8. The sample size is large, then the sample mean.
Sample mean will be close to the population mean.
Yeah.
Yeah. That's what I was
The
thinking.
last
Do you
one.
have do you have A, B, and C on yours?
No. I just
Oh, okay.
classified it. So
Okay.
third out
I'm
of
like,
4.
okay, I'm not seeing that.
Sorry.
The last one makes sense too. That's kind of like the direct definition we get from the readings.
Oh,
Says if the
yeah.
sample size is large, the shape of the distribution of the sample means will be approximately normal.
The central, yeah, the central.
Mm,
That's
Yeah.
the definition of you.
that's true.
That's like the last one.
Okay.
Yeah, that's like almost
see.
verbatim.
Yeah, I like that. I didn't read it.
Yeah, it becomes large, the distribution of sample means becomes normal, approximately normal. So
Got it. Okay. That's it.
Cool.
this is what I was talking about, because to me the wording is super close,
It's so close.
and yet they're so different. I'm like, okay, well that part hasn't come to me yet.
What is the mean distribution? I cannot stand.
Did it tell us anything about this?
Isn't it just 10?
Yeah.
It doesn't.
That symbol is the same as the sample.
Mhm.
Backwards.
It's not telling us anything about this population, right? I didn't miss that. Use this information.
Yeah, it just says
Population.
use the information. The standard deviation is the little O sign over the squares.
The mean is 6.
So the mean of the sample means the backwards U, so it's just 10, isn't it?
Yeah, for number 9.
Okay.
Yeah, the mean stays the same always.
And then the standard deviation would be the little O sign
No,
over
Well,
the
It wants the standard
square.
distribution of the sample mean. So yeah, you have to do the square thing, the square root thing.
Okay.
So that would be 6. So that's, so it's 1, right?
1. That's what I got. Are you
Yeah.
following that, Thor?
Yeah. Got it.
Okay. We got 1 for 10.
Yeah, I got that too.
Okay, cool. That was what we were talking about. I put normal for 11. What do you guys
Yeah.
think?
11.
That's what I put normal. Because both theorems talk about the sample size being large, so
Right.
large only makes it better.
Yeah. Oh.
Well, because it says regardless of the distribution, then I'd have to say that it's, would you say the central limit theorem? Because that's the only one that changes according to the increase? Or, yeah.
That deals more with the shape of the curve and everything.
What was that, Thor?
The central limit theorem, from what we said earlier, that's it's the shape of the distribution of sample means normal. So
And I think it would be the law of large numbers if it's
So,
on n.
well,
because the
so
law,
what we said earlier is giving the best explanation for central. We said that it was the shape of the distribution. So if we're saying that distribution here is normal because of large sample size, wouldn't the best response to justify that be then the central limit theorem?
that's what I think.
I agree with Thor on that one.
So unless our answer wrong.
Yeah, until the answer's wrong.
Because in the central limit theorem, the larger the sample, it can go from skewed and then it keeps going and keeps going until it becomes normal. So, but it's always normal the other way. So I think that the reason we can choose that answer is simply because it is a large number and therefore we can use the central limit theorem to back up
Right.
that thought
Yeah.
process.
I like how you have all those papers. It's cool. I guess
Why
I'm
I can
gonna,
only take 2 classes.
I'm gonna submit it and see what it looks like. We got 100%.
Cool.
Does any of us have questions? What do you say, Houston?
I'm like, if we got 100, then I'll go ahead and submit it then. Cool.
If anyone has questions with the homework too, like I'll do the same. You can feel free to ask me or I'll ask you guys too.
Yeah, that sounds good.
Cool.
Yeah. So
Um,
far, it's all pretty simple and straightforward. So I don't have any questions yet.
Yeah, I don't either.
did you see that he's doing a review on Friday?
No.
Yeah, for the test this coming up.
Yeah.
Yeah.
So I think it's 11. I think it's your guys' time at 11.
Okay, I'll put that on my calendar.
I don't know. I always feel like, I mean, I know that the earlier part of it's been easy, but sometimes I feel like if you go to their reviews, you kind of get a better idea of what's, but he's also recording it. So if you have classes during that time or something.
That'd be good.
Yeah,
That'd be
I'm
good.
glad he is.
So anyway,
Thanks for sharing that.
Cool.
All right, guys. Until Thursday.
That was
All right. Sounds great. See you guys Thursday.
See ya.
okay. Bye.